Hi, I'm Jeenesh, an Autodesk instructor, and today we're going to go over understanding why we use sketch constraints in Autodesk Fusion, how to identify them in our workspace, and how to correctly fully define your sketches. If you want to know what each constraint does specifically, check out our previous video on how to use each constraint in detail. Sketch constraints are useful tools that control your object geometry, position, and layout in the Sketch workspace. They allow you to make controlled and predictable changes to your sketches without the need for adjusting each of your sketch components individually. For example, these three sketches may look identical, but one of them has been fully constrained, one of them has been partially constrained, and one of them has no constraints at all. While it looks like it may not cause any major immediate issues, if further down the line I need to come back and make a change, for example, if I would change the height of each of these objects, all three sketches would behave differently, and only one of them would produce the goal that I actually need. If I have to change the height of my first object, you will see that as there are no constraints, I have less control over the object itself, and will have to individually change all of my dimensions to ensure my part behaves how I need it to. The second one, when changed, behaves slightly more predictably. However, if I require the circle in the center to adjust, I have to manually dimension each direction. The only one that behaves like I want it to is the fully constrained sketch, which adjusts automatically when I change the dimension, and does not move freely. It is important to be able to tell when different constraints are active in your sketch. When a constraint is active, an icon will appear on your sketch showing the corresponding icon for each constraint. For example, the vertical horizontal constraint can be seen active between both of these lines and can be seen here next to each one. This can occasionally get confusing when more constraints are added, to the point where if you're trying to fully constrain a sketch, it may be difficult to know what is constrained and what isn't. Blue lines on your sketch show that the line is not fully constrained. This usually means that its size or position is not yet controlled and may cause problems when adjusting your design. An easy way to check which constraint is missing is simply by clicking and dragging the line that is blue. The change will show what aspect of the line is not constrained, which then allows you to apply the corresponding constraint. For example, the most common shape that you may think is constrained but isn't is a simple square. First, we can sketch the square in our sketch workspace using the R key on our keyboard and plotting the two corners of the sketch. Now, if we click and drag on one of the sides, we can see that the size can be adjusted, and therefore we can apply dimensions to it. Now, instead of applying dimensions to all of the sides, we can use the equal constraint. This will make all of the sides the same size. Now, as the dimensions are applied, you might think that it is fully constrained, however the lines are still blue. It is not yet fully constrained, as the position has still not been fixed. Now, if you click and drag it, the square doesn't change size, but still free to move around. To apply a position constraint, we'll use the coinciding constraint and apply that between the square and the origin. Once all the lines turn black, you can see that it is now fully constrained. Another way to verify if your sketch is fully constrained is by using the browser at the top left of your workspace. Open up the Sketches tab and take a look at the sketch icon. When your sketch is not fully constrained, a little pencil will be present at the bottom right of your sketch icon. When your sketch is fully constrained, the icon will change to a little lock, similar to that of the fix or unfix constraint. Now, a lot of people will tell you it is essential to fully constrain your sketches every time you make a design. This is not entirely true. Fully defining sketches is not a requirement when using Fusion, however, more good practice. While it can help you save time when you're making changes in the future, if you're just using Fusion to make a quick one-off part, you may not actually need to use them. When you have a more complex design like this over-the-wall pipe bracket, there can be sketches that are dependent on each other. If these sketches aren't correctly constrained, when certain dimensions are changed, you may have undesired effects carry through when editing your design. This design currently does not have any constraints applied to it. Now, if I wanted to edit this design, and I adjust this dimension, the sketch does not behave how I want it to. We'll now go through how to constrain this model to allow desired changes when adjustments are made. To fully constrain this sketch, first we must fix the position of one of the corners of the component. We will do this by using the coinciding constraint and by fixing the top left corner of the wall bracket to the origin. We then want to use the tangent constraint to ensure consistent thickness throughout the part. From here, I want to introduce a dimension to define how thick my component will be at all times. We will then use that dimension when defining other thicknesses throughout the rest of the sketch. As you can see, all of these dimensions have been referenced to the original thickness dimension that I applied. As a result, when this original thickness changes, all of my other thicknesses will automatically adjust. If we ever get confused on what constraint has not been applied, we could simply click and drag on the blue line and see what changes about the object. This will inform us on what constraint is yet to be added. As you can see, the position of these two lines is yet to be fixed. We can introduce a dimension to fix the position of these two lines. In doing so, we'll also be able to adjust how thick the wall that we attach this bracket to can be. The following dimension is added to allow me to change how low the pipe sits when attached to the wall. All of the sketch for affixing the bracket to the wall has now been constrained. The only thing that remains is now defining what size pipe will sit in the fitting. Firstly, we use the collinear constraint to map these points so that they share the same axis. This keeps the ratio of pipe that is held consistent when changing the pipe diameter. Finally, we can add a dimension to the internal radius of the bracket. We will define what size pipe we want our bracket to hold. This fully constrains the sketch, allowing me to now make predictable changes to the design. Hopefully this video has provided a little more insight on how and when to use constraints to fully constrain your sketches in Fusion. Be sure to check out our other videos on constraints for information on what each constraint does, and if you found this video useful, be sure to leave a like and subscribe. Look forward to catching you in the next one.